Time for us to get started. So nice to meet everybody. I'm Dr. Chris Kane. I don't really care how you address me. I'm not the world's biggest stickler for professionalism, I guess we'll call it. I like to laugh. I like to make jokes. I try to keep them appropriate as frequently as I can. There are plenty of appropriate jokes. So feel free to call me Chris, feel free to call me Dr. Kane, whatever is comfortable to you will be comfortable to me. My goal is just to make you comfortable and feel like you can approach me with questions, approach me with concerns. That's really all I care about. I say this at the beginning of every class, but I want to make it public what my purpose is as the instructor. If I had one goal in this class, it is to, this sounds overly nerdy, but to maximize the cumulative amount of learning that happens in this classroom this quarter. And that means that I am here for all of you. I try to make myself as available as I can. Obviously, I do care about work-life balance, but if something goes on, my default is please just let me know. Let it be up to me when and how quickly I can respond to it. I try to be as fast as I possibly can be. So my office is just upstairs on the other side, along with all the other computer science professors here in the Catalyst building. I don't know, maybe a lot of you are new to the Catalyst building. Raise your hand if this is your first class in taking the Catalyst building. If that's the case, and you want to know where my office is, feel free to follow me after class. I'll try to do that in class early enough that you can follow me and then get to a class that you have if you have a class immediately after that. But my office hours, we are required to have 4 of them. I tend to have closer to 10 to 15 because I like to challenge people, but then I also like to be there to support that challenge. I'm not going to just throw you off the deep end and leave you to suffer. I want that learning to actually take place, and that's not going to be the case if I get up and leave, if I close my door, if I don't instill that level of trust that I am here for you. So if there's anything you take away from today, please give me a chance. Give me a chance to be there for you and to maximize the learning that you get out of this class. And I will do my best to do that trust justice. So that's my office hours. I have 10 to noon. I guarantee to be in there every day. That's between my 2 classes. So I will have my door open. I will be there as frequently as I can be. If I am not there when you stop by, that usually means I've stepped out for a moment, and I will be back as soon as I can be. I also do have 1 to 3 available upon request. There are sometimes things going on in that block, so I can't make them office hours. But if 10 to noon really doesn't work for your schedule, I will find time to meet with you. I will find time to get those questions answered and to work through whatever it is that you're going through in a way that you are satisfied with. That will involve some back and forth, that will involve some time. I don't necessarily do office hours individual. If I find that people have the same question, I will invite multiple people into my office at the same time so that you're not sitting outside my office wasting your time for a long period of time. If that becomes a class-wide affair, that has been known to happen in the past, not usually with this class, but some of the upper division courses, so I will occasionally have the entire class follow me back for class part 2 in my office. Then I might move it to a classroom or a lab, something of the sort. If I do that, I will have a note on my door that says office hours have moved to and the destination where you know you can come find it. All right. We can read most of this on our own. The important things are textbook is optional. I find this textbook to be very useful. So I highly recommend at least having it on the side. I don't know if that helps you to understand. My goal is to not make this textbook mandatory. You should not need to reference this material to understand what is going on. Everything that is going to be on an assignment, on an exam, will come directly from this class and material that I give you in this class. What it will be useful for is if you want some other way of understanding it, some other way of explaining it. I like to think that I can explain things in different ways if what I'm doing is just not working for you. This textbook is a good reference. It also happens to be written by one of my old undergraduate professors. That is not why I chose the book. I chose the book because it is the best. But I happen to know this man personally. He's as nerdy as I am. He spins fire. In general, I give this so that you know that if something has happened to an email, I guarantee I will respond to your email within 24 weekday hours. It's almost always sooner than that. But at the 24 weekday hour period, that's when you should send me a follow-up that says, hey, did you get my last email that I sent? Because it's important that you get a response within 24 weekday hours. If I miss something and you send a follow-up, I will get to that as soon as I see it. I will interrupt whatever I'm doing because that 24 weekday hours has elapsed. And that doesn't mean your response might take an additional 24 weekday hours. Again, that communication is important to me. That is a mess up on my part, so I'll take the blame for it. Because especially that it is winter quarter, it's important that we have figured out what we're going to do in case of moving to remote learning. That's what the institution has decided that we are going to do. Rather than canceling classes, we are moving to remote operations. And so that means that for the scope of this course, I will have some announcement about what that means. The default expectation, though, should be that we are going to meet synchronously remotely. So there will be some kind of Zoom session at this time at the same link that is also on Canvas. And I can show you exactly where that is. So I make very good use of the modules, and you can see that there's quite a bit here that is hidden that we'll reveal as we get to it. But what's visible right now are these course resources, both the Zoom link and the entirety of my YouTube channel. In case you want to watch a lecture back, that is where that will be. I will be uploading these recordings as I am able. Sometimes it is not always same day. It is frequently same day if someone has said, I am missing for some reason and I want to be able to catch up ahead of tomorrow's class. But that's usually the bottom of my priority list at the end of a day. Sometimes I don't quite get to it, so a batch of 2 or 3 days may come up at a time, unless I'm aware that people have been missing for some reason. If you're going to miss class, please send me an email, let me know, and that just helps me to plan my day so that I can better prioritize getting up lecture videos that are going to be needed right away. They're also useful for studying for exams ahead of exam study periods. So there will also always be an exam study period in class the day before an exam. What else is useful? Back to the syllabus. I guess I can talk about this. I don't cold call. I hated it as a student. Gave me immense anxiety. I don't do that to anyone, but the pace at which I hold the class requires some kind of interaction. I don't want to just lecture at you like I have been so far. This is actually very uncomfortable to me to not have some back and forth or have you doing something, because otherwise it's boring. So my expectation is that I will be asking questions, but I'm not going to cold call on you. Self-advocacy is very important to me. Again, I am not here to judge where you are. My goal is to figure out where you are and figure out what's going to help you learn the most that you can. Please don't feel bad about whatever prior level of experience you have, however your past courses have gone. Doesn't matter to me. What matters to me is what you currently know, what your confusions are, and how I can help. So the best that you can do is to be fully straightforward and honest with me about that. That's how I'm going to be able to help you the best. Please don't feel afraid to come ask for help. This class will be challenging enough with the assistance. I don't say that to scare people. I say that because I want that learning to happen. That learning isn't going to happen if people aren't challenged. So this is going to look very different probably from past programming courses you've taken either here at a local community college, I tend to have a slightly different class outlook. Or I'm not writing a bunch of code ahead of time and saying, add something to this code. We're going to be writing everything we do this quarter from scratch. And assignments are going to be based on that scratch code that we write. I will publish everything that we write. And after we write it, that's going to become the basis for the assignments. Question?
Are we gonna need a, oh, I forget what they're called, the virtual box and, are we gonna need our own, like?
Your IDE?
No.
An IDE or a runtime environment?
Yeah,
So everything should be possible in IntelliJ. I will be using Eclipse, and that's mostly just to give you some experience with different IDEs. I could easily do everything we're doing this quarter in IntelliJ. Really, everything here should be IDE independent. Whatever you would like to use, you are welcome to use as part of submitting this. I find that the two most engaged IDEs are Eclipse and IntelliJ. They offer the most features. I also find that I frequently don't like that level of feature, so I am a huge VS Code fan on Windows for that. I do Emacs development in Linux environments because who needs syntax highlighting? It gets bad sometimes, but I have fun with it. Grading, I've split it 50-50 between homework and exams. I actually don't like that exams are weighted this heavily, but I think they are this important in this class. I will say this throughout the course of the quarter. This is the foundation of the rest of your computer science education. You will be using what you learn in this class in just about every class you take from here on out, regardless of the path that you take, whatever it is that you're interested in. If it uses computer science, you will be engaging with this material. So I take it very seriously, and I'm actually quite honored to be teaching you this material because I know how important it is. It's incredibly important. But I also don't like weighting exams heavily. Yeah.
So is the exam that's gonna be like on the 9th of every week, is that just the final exam?
I don't really love cumulative exams, so I'm going to try to break it into exam. There's not really going to be a final exam. We need to do something during that finals period, but I can talk a little bit about what the pace and structure of this class allow for me to do in the second half of the class. The last time I taught this course, I covered the requirements of the course in about 7 weeks, which left 3 weeks to help students with the next step. The next step is algorithms. And going from data structures to algorithms, we have historically had a lot of difficulty with the first part of that course. So I'm going to try to bring forward some of that material to make that transition less difficult. And then the last week, I cover some internship and job searching type of content so that you know what you should be working on at this stage, what you should be thinking about as you think about trying to interface with industry, getting some experience. What will being successful at that process look like? Question?
What happens if we like miss an exam or just, take it that day?
Let me know, I'll work with you.
Okay.
Unless you're avoiding taking the exam intentionally, I will find some way to make that happen. If there are something that happens outside of the scope of, I'm pretty easy to work. I try to be pretty easy to work with. Just let me know as soon as you know, and communication really makes the difference there. If you know that, hey, something has happened, or hey, something's come up, I'm out of town, I have something happened, let me know, we'll figure it out. There is one big stipulation down here that is actually quite important. I do this in just about all of my classes, and that's because of, I see the faces around the class. I hate this as much as just about everybody else does. I will curve this until it's where I want it, basically. But the idea is that if you have learned this material, you should be able to apply it. And I don't write regurgitation style, very closed-ended exam questions. I write very open-ended questions. They're a pain to grade. My graders hate me. So what that means for this class is that you will have the opportunity to. There's not one right answer to most exam questions. It's apply this and work with the kind of question, show that you understand it to a level that you give the credit, which means there's also generous partial credit available for every question. By anticipation, the goal of this is mainly to prevent people from using AI to circumvent learning rules. And it's something that I have found is the single most successful metric or way to do this. It's that if I am as available as I possibly can be, if I structure the class in a way that is, you will see this from every example that I do. I will go through it in painstaking detail. I'll write it out. I'll try to talk about it in different ways. If someone says, I don't understand that, I'm not going to repeat exactly what I just said. I'm going to find another way to say it. I'm going to find, unless someone said, repeat exactly what you just said. I will find a way to help you with this material. This class is going to be a lot of work. There's going to be a lot of back and forth. But historically, the feedback that I've gotten at the end of the course was, this is very useful. I feel prepared. And that's the goal of the class, is to be able to take where you are right now and where you need to be to get a lucrative job in this field, doing something that you're very interested in, and find a way to get as close to that as possible. This should not be difficult to do if you're doing your own work. I don't write exams. I give extra credit on my exams if I notice that exam scores are low. I will find a way to curve the class to where I want it to be. The only thing that should be scary is if you have been relying on AI and you plan to continue to rely on AI to do your work for you and to get those learning outcomes. There's a time and a place for AI. Once you know the material, minimizing time, wonderful. Basically, once you have a job in the industry, all hands off. It's a very useful tool. While you are learning, it is something that prevents you from being able to do what you'll need to be able to do in a job. Synchronous class is synchronous. I do expect people to be here. There's a lot of interaction that happens in an in-class environment that doesn't happen in a remote environment. If people join remotely, it's very difficult to be able to ask questions. That said, I always have chat up here. If I'm sitting in this chair and coding, for instance, I will turn this monitor to face me. If you are remote, feel free to engage with class. I tend to see it faster than most people who hold Zoom meetings, or so I have found. I don't know if you all have experienced that as well. You ask a question in chat, it just goes off into the abyss and is never answered. I try to be much more aware than that. That said, again, I prefer people to be in class where possible. One thing for exams, I will always allow you to bring a double-sided entire piece of paper. You can put on that whatever you want. I'm not going to collect it. I don't care too much what's on it. I design my exams around it. I design them so that that 8.5 by 11 sheet of paper is as useless as possible. What that means is the questions are going to rely on your knowing what material was covered in class so that you can apply it. You can use it to solve a new kind of problem that you haven't seen before. But if you don't know what it is, that means that you can't engage with the problem at all. So if you throw anything definitional, anything of the sort on that piece of paper, you can reference that to get a sense of what the questions are asking. It won't help you directly answer just about any question on the exam, at least if I'm designing it correctly. With that said, feel free to bring that in. I find that rather than making it open book, open notes, you're more likely to learn while you're doing that, translating onto the piece of paper, to where if I collected the pieces of paper during the exam and threw them all away, I don't think there'd be too much detriment. I'm not going to do that. That's me. Pretty typical other exam related stuff. I do like to say that exams have a week turnaround. Assignments should have a week turnaround. I guess that gives me an opportunity to introduce the PA grader for the course. Want to say hi?
Hi, everybody, I'm David.
So David will be working with us throughout the quarter. He'll be doing a lot of the grading, but I will be doing a lot of talking to him during that grading to get a sense of where the class is, the temperature of the class, the health of the class. That is very important to me, in addition to the individual conversations that we'll have throughout the quarter as I get to know you.
I'll post them up to our screen, you can find me in the cubicles on I.
Yeah. If anyone, for most of you, this is your first class in the Catalyst building, I will also walk you by David's cubicle so that you know where to find them as well. Any questions so far? I've done way too much talking.
I did have a question
Yeah.
about the, like, exam average.
Yeah,
So say you are on kind of the lower end, you're not sure if you're gonna meet that exam average. What would, would there just have to be a discussion with you about like, okay, what can there be as like, an event to get past that, or?
yeah, I'd be happy to do the math with you to figure out exactly what needs to happen. I tend to be pretty generous with my curving. If you're close to that, but I've been working with you all quarter, I know you're not using AI, I know you're really putting your everything into this. I take that into consideration. I take effort way more seriously than I take performance. So if you're showing me that you want to learn the material, that you're engaging with the material, you're showing up to office hours, you're asking questions, that's what I really care about. And that will make a difference in at the end if you're on the boat. Yeah,
For like activities that we do in class, like is it okay to like do all, we go out there, it's like really like anxiety.
oh yeah, absolutely. You will always volunteer for anything that you do. I'm not gonna call on someone to say, come up to the board and do something. That will always be your volunteering.
What if you volunteer, you go out there, you put yourself out there?
Yeah,
Like,
that's fine. I think that's a learning outcome, right? I'm not here to judge people for what they do, but maybe that helps me to see a common misunderstanding. If you make that mistake, it's likely that you're not the only one who makes that mistake. I don't think anyone is here to judge each other or to expect that we all go up to the board and produce perfect work. I think that, at least from my perspective, the goal is to learn what is it that you are struggling with so that I can help you with that? Or what are those misunderstandings so that I can help you not just identify them, but understand why you made them and what we can do to avoid making similar kinds of mistakes in the future. If they happen again in the future, that's fine, right? We're all trying our best. We're not trying to mislead. We're not trying to lie to each other. We're all here to do our best. So I would argue that try to put yourself out there. Try to do something that's a little bit outside of your comfort zone. I wish I had done that more as an undergraduate. You would never anticipate now that I was a shy, recluse introvert in college that never volunteered for anything and had massive panic attacks whenever there was a chance I might get called on. You would never guess that now. And the difference is you put yourself out there, you're forced to stand up in front of a class for a living and talk to them as they sit there and stare at you and judge you, whatever. What's important is after you graduate, you're not going to see many of these people ever again, unless you really want to. So what's going to stick with you is what you learned in the class, what you admitted that you didn't know and were able to correct through that process. So I will respect the fact that you're putting yourself out there, and that's not easy to do. I respect that. Yeah.
Last thing for me is that, I'm like, not super certain, but, how is this class gonna line up with, the gate testing and that?
Yes.
In the quarter?
So the goal of the first 5 weeks is to maximize the 8 pass rate. I tailor everything that we do directly to the learning outcomes on the 8, because I know just how important that is, just how stressful the 8 is. The week of the 8th, we will be doing quite a lot of review. In fact, I anticipate taking a couple classes and saying, there's no goal for this class except ask me questions, tell me what you don't know. I'm also the advisor of the ACM club on campus. And there are always 8 study sessions ahead of the 8th that they put on. So I'll be advertising that, we'll be doing practice problems, we'll be doing everything ourselves, so that nothing on the 8th is a surprise.
And age sign up is
Soonish.
okay.
Yeah, I don't administer it, I'd have to talk to Tony. Tony Sian is the person to talk to about anything ape related. He will know, but I take that very seriously. I will be ordering an 8-ball for my office and putting tape over the 8 and putting ape. So it'll be the 8-ball, you come to my office, shake it up, and get a sense of how it's going to go, if you believe that. But
Sorry, so I'm new to EW this quarter.
yes,
What is that?
it's the advanced programming exam. It is a prerequisite to a lot of the upper division courses. And so it's something that people take during either while they're taking 212 data structure, design patterns, which is going by the wayside at the end of the year. If it's on your degree audit, you do not need to take it. It's gonna go away. That said, I will be building some of that content into this course as well, so that you meet some of those outcomes. And just for your own knowledge, you don't actually have to take the course.
Well, how happens if we don't pass any exam for time?
You get 3 tries before we sit down with you and try to figure out what is your future in computer science? Are we gonna be successful with a 4th attempt? Is there a similar field that
Do most people pass on the first time? Like, what's
depends?
the pass?
So I'm going to very quickly. Any other questions or concerns before we move to, I guess, whatever is next? What is next? I try to keep weekly due dates the same. So you can anticipate homeworks will be due on Wednesdays. I like middle of the week homeworks because it gives you a weekend to work on them. And then it gives you some time to back and forth with me in office hours and continue to work before the middle of the week. And I don't want the assignments to collide with the exams. I don't want you to be worrying about, should I prioritize my homework or should I prioritize an exam? So for this class, exams will always be on Fridays. This may change as the schedule dictates. If I want to provide extensions on things, we cover something and it just doesn't line up with that particular day in a way that is easy to work with. But in general, I want to set that expectation early and do my best to meet with that just for ease of scheduling. Typical university policies, you can read those anytime. I try to have a reasonable course schedule that I stick to. I see that my dates are off by 1 day. Oops. I'll fix that, probably. Someone reminds me. So we're going to be starting the course, making a linked list from scratch. We are going to be live coding it in class from scratch. Once that is done, it's going to turn into the first assignment. Once we have a complete singly linked list, as well as some additional features for it that maybe you heard about in 211, maybe you didn't, but we're going to add those features on top of our linked list. And then the first assignment is going to build from there, basically saying, take this code that we produced in class and add some functionality to it. It's not going to be missing functionality. You're going to be creating kind of some parallel code that uses this code to produce something similar. We're going to move from that into some basic sorting. That sorting is going to be implemented into our linked lists. We're going to use a design pattern as we do so. We're going to go into recursion. The next assignment is going to be to add some recursive functionality to our linked lists. So you can see that we're really going to be building on this linked list idea. Everything we do is going to be tied back to what we are doing. So it's very important that you take this very first week or two very seriously. Any misunderstandings you have about that linked list will probably come back at some point. So it's a great time to hit the ground running with regards to advocating for yourself, asking for assistance, making sure that you feel confident in the material that is presented. I will prioritize that above everything else. I love office hours and office hour interactions. That's probably my favorite part of the job. I want to get to know you. I want to get to know your learning. I want to get to know what you want to do after you graduate. What interests you about computer science? How can I help you to take the most useful electives moving forward, and how can I help set you up for success on that path? All of those questions are very interesting. We're going to add, we're going to write stacks and queues using our linked lists. They're going to be the underlying structure. We're going to go into some more advanced. You can see that by about week 5, we've covered everything that's going to be on the 8th. Complexity and stacks are not. So really by the end of week 3, we've covered the material that's going to be there. The way that we create our linked list is going to help with some of the other outcomes for the 8th. So we'll do some 8 prep on week 5, move into the more advanced data structures, hash tables, some advanced sorts, trees and binary search trees, and that's where this class is supposed to end. It's at the end of binary search trees, but we're going to start talking about some graphs and some graph algorithms. I also want to spend some time doing practice problems. So in any kind of interview setting, you will be asked to do some kind of live coding exercise. I want to emulate that a little bit, not necessarily in an environment that is that high stress, but I would like to provide some practice problems and say, all right, solve this. I don't care how you solve it, but talk me through it. And then I will also solve it, and we can talk about how the different ways we have of solving the problem. As we start talking about computational complexity, we can start talking about, are there better and worse ways of solving the problem in terms of how long they're going to take to run, or how long it takes you to find a solution. All right, that is the syllabus. That was longer than I'd hoped, but that's all right. Questions or concerns about how the course is going to be run, expectations, concerns that you have about interfacing with it? Yeah.
Study group?
So yeah, absolutely, study groups are a good idea. Are we all members of the CSCD Discord? If we are not, I highly recommend it. So that is, I don't know exactly where it's found. I can send out, I'll post it to Canvas. I'll post an invite link to Canvas. And that will allow you to, so there's a text channel for every course in the major. Feel free to post in the CSCD 300 channel, general channel, anywhere else. And usually there are people more than willing to help, or if you want to post about forming a study group, finding some friends, finding some people to work with, that's a great place to start. My goal is to get to know you all well enough that maybe you come to me and ask that, and I say, I know 3 other people who are also looking for a study group. Why don't I get you all together? Other questions or concerns? We're gonna start off with just a little bit of introduction. Again, I try not to do too much lecturing without actual examples on the board, or you will be doing a lot of live coding in this class during class time. So recommendation is to bring a computer. If you are unable to bring a computer, that's okay. Write some code on paper. No easy way to run it and ensure that it works, but I will be live coding it as well, and I'll be uploading everything that I live code to Canvas. All right, syllabus, we did that already. We're going to start next with what is a data structure. This class is called data structures, but any preconceived notions? What do we think a data structure is going into data structures? No, all right, so linked lists as an example of a data structure, absolutely.
A way to sort and organize data.
Store and organize data, I love that. So yeah, we need some way of exactly that, storing and organizing data. We need some way of keeping it so that we minimize the time if we're trying to locate a particular aspect of that data. If we want to put new data into that, we want to minimize the amount of time that it takes to add data. If we want to remove data, we want to minimize the time that it takes to remove that data. And based on exactly the data that we are working with, a different structure may make more or less sense. there are multiple different structures that will work at the same time for some different application. As you start taking software engineering types of courses, working with clients, you will be the tech brain behind what is it that they want to accomplish? How can you ensure that what they want to accomplish is done efficiently? You're not going to be able to have that conversation with the client. They don't understand that concept. But you can take their needs and convert that into some technical specification of a way of solving those problems. To be able to do that, you need to understand what are the different kinds of structures, what are the benefits and detriments of all of those structures, how do you select an appropriate structure given a situation. So my definition, and again, I'm not going to ask you definitions on anything, but it's a format for efficiently organizing, processing, retrieving, and storing data. We have one example. We said that a linked list was an example of a data structure. What are some more? What are some more that you've seen?
Array.
Array? Yes, an array can take absolutely multiple different values of the same type. So we're making a distinction here between a structure and a variable type. A variable type can store one piece of information of that type. A structure can store many pieces of information of a particular type in some kind of structure. So an array and a linked list both store in kind of a one-dimensional type of structure. They have a location. You can add at the end, you can add in the middle, you can delete the first instance of a particular value. You can query whether a particular value is in the structure. There's all sorts of ability that you can do with that structure, but it's all for a one-dimensional line of data. Until you have multi-dimensional arrays, then you can have a two-dimensional or a three-dimensional representation.
Would that also kind of fall under like building linked lists and that sort of stuff?
Yeah, different types of linked lists. Yeah, they're the same kind of structure if they can do the same subset of operations. They may do them slightly differently with different associated runtimes. It might take one structure longer to find and another structure longer to replace. Another longer to delete or insert or anything else we could do. So we've seen an array list, which is just an object implementation of an array in Java. We've seen a linked list. There are plenty that we haven't seen, maybe from the syllabus. Any others that we are aware of that we haven't covered?
Collection.
Some types of collections. That's really it's a really abstract idea. So it in and of itself is not necessarily a structure, but it would be a set of structures that are all collections of some kind. Yeah. Stacks. That is a structure. Binary trees are structures, yep. So we will see lots of them, yeah. Hash tables, yep, that's another one. So lots, we didn't talk about queues, we didn't talk about graphs, but yes, stacks, queues, hash tables, trees, graphs, heaps. We'll talk about all of these in this class, and they will all show up again in some capacity in algorithms. But I want to give you a very intuitive view of what each of these are, and we're going to live code all of these. So some course goals. Organization is very important, even in data. If you know where something is, you can find it efficiently. If you don't know where something is, it's going to take longer to locate it. So we like to be able to organize or provide structure for our data to minimize the time that it takes for us to do the common functions we might want from our data. We're going to see throughout this course that there are trade-offs to everything that we do. If we want to make gains in one metric, that usually means we're going to lose out. We're going to have a detriment to some other metric. So gains in one metric, met with counteracting losses in another metric. We will find though, that for instance, you can imagine, we're familiar with the concept of a database, even if we don't know too much about them, it's just a place to store a bunch of data. Imagine now that your client comes to you and says, all right, we're going to add a bunch of data into this database, but then it's going to be finalized. Never again are we going to need to add new information to the data, but our live service wants to minimize the time that it takes for an end user to get feedback or to get something out of the database. This tells us that it's much more important to be able to find than it is to be able to insert. So if you know an associated structure where find is incredibly efficient, but maybe insert is a little bit less efficient, for that client's needs, that's the structure you want to implement, rather than one where find takes a long time and insert takes longer. I like the shoving clothes into a dresser example. If you neatly fold and have places for your clothes, it's very easy to locate very quickly. If you shove absolutely everything into a single dresser, especially if you have not paired your socks, how long does it take to locate a pair of socks? Sometimes that can take a little bit. So the more organized it is, the less time you end up spending on the actual searching. But that said, to get it nice and folded, that takes some time. So there's a trade-off between the time that you do up front for future days, minimizing the time it takes you to put together your outfit, versus the time that it would take if you just shoved it all in there. All right, on laundry day, it's nice and easy, but every day after that is going to involve a little bit more searching. So that's an example of the kind of trade-off that we're going to be seeing very frequently throughout the course. So we're going to see very commonly used data structures and their applications. We want you to be able to describe the efficiency of each of these operations and the efficiency of each of these structures. So we're going to introduce you to both terminology and the math underlying how we're going to be able to measure structure and algorithmic efficiency. You've actually been writing code for a while now. This is relevant to everything that you've already done. So you can go back to some of the code that you've written and actually go take a look and do this analysis on what you've already written. It will also be relevant to everything you ever write from here on out. What's an abstract data type? Is this something that you have run across in 211? Yeah.
Abstract is just a data type that doesn't have a necessary, like, it's not necessarily integer or anything, right? It's just something
That
that.
would be a generic.
Uh,
Generic. That's a great idea. That is something that is, I think, on the next slide.
Ah.
Very important concept. But an abstract data type. Have we heard that term before? Yeah, it kind of, it describes. I will hold off on that. Let's actually do this exercise. 2 minutes. Do this exercise in your head. So emulate the following instructions in a list structure. So we're going to insert 16 at the end. Insert 9 at position 0. Set the element at position 1 to 22. Insert 12 at position 1. Insert 18 at the end. Remove the element at position 2. I'll come back to this at the start of next class as well and actually draw it out. But I want to get a sense of all I want to do here is the question here at the end. So the question after this one, the final list, we'll come back and have an answer for that at the start of next class. But the real question, in your head, were you using an array type structure or a linked list type structure?
I didn't link list because it's easier for me to.
Yeah. Anyone else? Were you thinking of it in terms of an array or linked list?
All right.
Yes.
Again, right.
Yeah. Now, the real question, does it matter? It doesn't matter, right? Whether you use an array-based list or a linked list-based list, you're going to get the same answer. Because both of these types of lists can do all of these things. All that's different is the underlying structure of how that data is interconnected. So an abstract data type, an example of that is a list. When I say list, I'm not specifying an array list. I'm not specifying a linked list. Those are both different list implementations that can do all of the same things. You can make an array list to do everything that a linked list can do, and vice versa. The only thing that's different is the underlying efficiency of some of these, of some of the functions that we might want to do to it. So I'll leave you on that note, thinking about how a list is an abstract data type, and we will come back and draw out this idea at the start of tomorrow's class. We'll also get into some real live coding almost immediately. Hopefully, this is one of the only days where I will do most of the talking at you. If you want to follow me up to office, feel free to stick around. And I will show you around.